Water is one of the most important substances on Earth. Did you know that 70% of your body is made up of water? So water could be drinking water, water that you bathe with, water that you wash dishes with, or even raindrops from the sky. So water is made up of a molecule called H2O. H2O consists of two positive hydrogen molecules and one negative oxygen molecule. Many of these bond together to make up the water that you see. These bonds are called hydrogen bonds, and hydrogen bonds are possible because water is polar, meaning that water is slightly positive as well as slightly negative. So today, I'll be talking about the 6 characteristics of water. 1. Water has high specific heat. Number 2. Water has a high heat of vaporization. Number 3. Water has high adhesion. Number 4. Water is a universal solvent. Number 5. Water has cohesion tension. Number 6. Ice floats because water is less dense. So, water has a high specific heat, which means that water has the ability to absorb large amounts of heat, which allow water to resist changes in temperature, which would be very important for 2 main examples. Number 1, your body temperature. So it would help in homeostasis. To maintain your body's temperature, heat is absorbed, and so you can maintain your temperature and stay alive. Number 2, in coastal regions, there are many organisms living in the water, but when it becomes winter or when the water starts freezing, there needs to be a way for the organisms to live in that temperature. Because the water has such a high specific heat, it can trap heat and resist changes in temperature, which means that the organisms would be able to stay alive. So water has a high heat of vaporization. This means that water needs a very high temperature to evaporize the water. For example, on your skin, if you sweat, the sweat needs to vaporize. And when that heat is evaporated, then you feel cool. So the evaporation of sweat would significantly cool your body. So number 3, water has a high adhesion properties, which means that water can stick to any other substance. This would be very desirable for plants, where the water from the roots needs to travel up to the stems and the leaves and the actual flower. So in this case, we would be using capillary action, which helps the water flow from the roots of the plants to the leaves in order for it to survive. As I said before, water is polar, and so this means that it could be a universal solvent. First, it would dissolve all polar substances as well as all ionic substances. So to prove to you that water is a universal solvent, I'm going to take water and melt something called sugar. So I put a teaspoon of sugar in, and it's at the bottom now, but if you stir a little, it's all gone. This proves that water is the universal solvent. So as for the cohesion tension, you could think of surface tension. For example, if you see this water skaters, the insect is on the water and it doesn't sink, which means that there's surface tension on the water. So it allows the insects to walk on the water. Another example would be how water can travel up even in a tree without interfering with gravitational pull. And maybe another example you have experienced, diving into the water and belly flopping. That hurts. Okay, so this is a cup of water with ice on the top. So ice is able to float, and this is because ice is less dense than water. So basically what happened with that ice was there's oxygen on the top of the water, and that oxygen travels to the bottom, and nutrients are made at the bottom, and they rise to the surface, creating a cycling of the nutrients, which is also necessary for the health of water, but